Hello juniors, today we're going to see electronic assignment 20, solving quadratic equations. I'm going to try to make this video as quick as possible as it is a topic that you should already know, and if not, I encourage you to pay close attention to this. So, solving quadratic equations. The objectives for this class: understand the terms of a quadratic function, write the quadratic equations in general form, solve quadratic equations, and apply quadratic formula to solve problems. So these two are the main things for this class. Okay, so this is just a brief review of what we already saw. The different characteristics of a parabola, the intercept, the vertex, the axis of symmetry, the sign of A, which determines if the parabola opens upward or downward, and so on. So I'm just gonna go through this quickly. Here's the important part for today. What does it mean to solve a quadratic function? Whenever we're asked, solve the following quadratic function, what do we need to do exactly when the word solve appears? Solve implies this over here. It says, solving a quadratic function is to find the value or values of x for which the function f of x equals 0. Okay, so basically solving means finding the x-intercepts. Okay, that's why we call the x-intercepts, we also call them roots, or in some cases we also call them solutions. Okay, that's why whenever you read the word solve, that means that we need to find the x-intercepts, or we need to set the equation or the function to 0. Okay, so there are 4 ways to solve quadratic equations. Number 1, solving by factorization. Number 2, solving by completing the square. Number 3, applying the quadratic formula. And finally, number 4, using the GDC. We're going to see all of the 4 different ways to solve quadratic equations in this class. So, the first case is solving by factorization. It says, if x times y equals 0, then either x or y should be equal to 0. This property can be expanded to this: if x minus a times x minus b equals 0, then x minus a equals 0 or x minus b equals 0. Okay, so this is called the zero product property. Let's see the examples just to see that this is a pretty easy concept. It says, solve these equations by factorization. So we have this case first. You see that whenever the word equation appears, equation means that we set the function to 0. If we write it this way, x squared minus 5x minus 14 equals f of x instead of 0, we're talking about a function, okay? But when we have this same expression but set to 0, we're talking about an equation. That's the difference between a function and an equation. Function can take different values here, but the equation, we generally set it to 0 or to any other number, okay? But we don't have the f of x appearing when we talk about an equation, okay? So that's the difference between function and equation. So, how do we solve this by factorization? Basically, what we need to do is apply case 5, which is multiply add, right? A pair of numbers that multiplied will give me negative 14 and added negative 5. That pair of numbers would be negative 7 and positive 2. And this is set up to 0, so equals 0. So the two solutions would be x equals 7 and x equals negative 2. Okay, and that's it. With these two values, we solved the equation. So those are the x-intercepts or roots or solutions of this equation. Okay, let's go to exercise B. We have the same situation. We need to solve this. In this case, we cannot apply case 5. We should rather apply case 6. And I'm going to show you the way I like to solve case 6, which for me is the easiest. So what we need to do is we need to square the first term and the second term. So this would be basically 9x squared plus 2x minus, no, we don't square the last term, we multiply it by this term, by 3. So minus 15 equals 0, okay? And then we open up two parentheses, and we write the square root of this term, which is 3x. And then we need to find a pair of values which multiplied give me negative 15 and added give me positive 2, right? Just like if it was case 5 in this case. So the pair of numbers in this case would be positive 5 and negative 3, right? Remember, this is always set up to 0. And as we multiplied the first equation by 3, remember we should always divide again by 3 in order to maintain our equation, okay? So you see that in this term over here, we can find a common factor, which is 3. So if I rewrite this as 3x plus 5 times 3, and inside I'll have x minus 1, and this is over 3. You see that the 3 always simplifies. The term that I initially multiply and divide at the beginning always gets cancelled out when I make the common factor. So finally, the equation would be 3x plus 5 times x minus 1 equals 0. Later on, I will post a video, a YouTube video, where it shows all of the different ways to solve case 6, just for you to remember, and try to stick up with one of the methodologies for solving case 6, and always try to use that in order to avoid confusion. So what will be the two values of x here? One is that 3x plus 5 should be 0. So if we solve for x, this would be x equals negative 5 over 3. This is one possible value of x. And the other possible value of x will be if we set this term to 0. So x minus 1 equals 0. So x equals 1 is another solution to this equation. Okay, so those are the two solutions for part B. Finally, for part C, I'm going to do that here. It says x times x plus 8 equals 5 times x plus 2. Okay, so this seems to be a little bit difficult, but it's actually not difficult. We just need to expand this, multiply, and then organize the terms, and we would solve this normally. So this is the same as saying x squared plus 8x equals 5x plus 10, right? So then if we organize this, maybe if I take this to the other side and set this to 0, it'll be easier. So x squared plus 3x minus 10 equals 0. And here again, we can apply case 5, right? A pair of numbers that multiplied give me negative 10, and that added would give me a positive 3. And that pair of numbers would be positive 5 and negative 2, right? So the values of x would be x equals negative 5 and x equals positive 2. These are my two solutions for this equation, okay? I'm gonna separate this just to avoid confusion. There you go. Okay, so that's how we solve by factorization. I think we have some extra examples. Yes, it says find the solution to each equation. And I added these two examples because you would see that the easiest way to solve this is just to apply case 5 here. Sometimes students would tend to take this to the other side first to set this to 0, but in some cases that is not convenient to do. Why? Because if you do that, you will not be able to apply case 5, because you will not find a pair of values that multiply give you, this would be positive 14 and positive 10. There is no pair of values that give you that. But if you leave this just like as it is, we can apply multiply add in this side and then just leave the 11 on the other side, and you would see how to solve this. So in this case, I need to find a pair of values that multiplied give me 25 and added give me 10. Those would be positive 5 and positive 5, right? So this is the same as saying x plus 5 squared equals 11, right? And how do I do to solve for x in this case? Now that I have this squared, it'll be easier to just apply the square root, right? X plus 5 squared equals 11, and I apply the square root on both sides. And by applying the square root, I can eliminate this squared value here. So this would be x plus 5 equals the square root of 11. So finally, the value of x, remember something. Whenever we do square root, there's always a plus or minus sign in front, right? Do not forget that. Whenever we apply square root, we need to write plus or minus, okay? So the values of x would be plus or minus the square root of 11 minus 5, right? So one answer would be positive root 11 minus 5, and the second answer would be negative root 11 minus 5. These are my two solutions in this case. Okay, so I hope that's clear. Then let's see exercise B. Same thing, right? Instead of, let me see if it's convenient. If I take the 8 to the other side, I will get negative 4 here. Negative 4, no, I will not be able to solve that. So once again, I need to leave it just as it is and do case 5 in this side. So this would be x times something, x equals 8. So a pair of values that multiplied give me positive 4 and added negative 4. That will be negative 2 and negative 2, right? So once again, I get the same thing, x minus 2 squared equals 8. And then I apply the square root to both sides of the equation, square root. I can eliminate the square root on this side, and I'll get x minus 2, you can just leave it without parentheses, equals root 8, plus or minus root 8, sorry. So finally, the values of x would be plus or minus root 8 plus 2, okay? Do you know how to take the square root of a number without a calculator? Or at least simplify the expression, because you know that root 8, if you put this in your calculator, you would get 2 root 2, this is considered a simplified version of this. So how do you do that? You see that if we factor 8, just as you did when you were in 7th grade maybe, if we factor this, you'd see that if we divide this by 2, then we'll get 4, by 2 we'll get 2, by 2 you'll get 1. So 8 is the same as saying 2 cubed, right? 8 is the same as saying 2 to the power of 3. So if we rewrite that, I'm going to do this step by step here just for you to understand this. Plus or minus square root of 2 cubed plus 2, right? But when I have 2 cubed and I have a square root, I can take 2 outside, 2 to the power of 2, I'll take it outside as 2, and I'm left with 1, 2 inside the square root. So finally, this would be x equals plus or minus 2 root 2 plus 2, okay? So the two possible solutions would be, let me take this a little bit up. The two possible solutions are x equals positive root 2 root 2 plus 2 and negative 2 root 2 plus 2. These are the two solutions for this exercise. Okay, so I hope this is clear enough. So this is it for factorization. I'm gonna show you the second way of solving quadratic equations, which is by solving by completing the square. This method is not used a lot, but it is kind of important to later on demonstrate where the quadratic formula comes from. We're going to be studying that in the later classes. So it says solving by completing the square. To solve a quadratic equation in the form x squared plus bx plus c equals 0 by completing the square, and these are the steps we need to follow. Number 1, write the equation in the form x squared plus bx equals c. So we take the independent term to the right side. Then it says add b over 2 squared to both sides and write the equation as this over here. We're going to see this in an example just in a second. Number 3, factorize the perfect square on the left hand side. Okay, so you see that if we write it in this way, we can factorize this and turn it to x plus b over 2 squared, which is exactly what we have right here. I'm going to show you that in a second. Okay, then step number 4, take the square root of both sides and solve for x. Okay, so let's see the example here. Example 4, solve each equation by completing the square. So we need to solve this by completing the square and this by completing the square. So how do we do that? We need to complete the square in the left side of the equation. And how do we do that? Let's follow the steps. First of all, we need to write it this way. This is already written this way. You see that this is x squared plus bx equals c. So the value of b in this case is 10, right? And the value of c is 6, but we don't care much about c in this case. Then for step number 2, it says add b over 2 squared. That is half of this value and then square that value. So b over 2 gives us 10 over 2, which is 5, right? So if we square this value, b over 2 squared is 5 squared, and we get 25. So in order to complete the square, we need to add a 25 in both sides of the equation to maintain the equation, right? So if I rewrite this as x squared plus 10x, and I add the 25, and I do that on both sides of the equation. Remember that anything that you do on one side, you must do on the other side in order to maintain the equation constant, okay? If you don't add this 25 over here, then the equation will not be an equation anymore because you're unbalancing the equation by adding a 25 to only one side. Okay, so we did this to complete the square. What does complete the square mean? It means that we can rewrite this, or we can factor this as x plus 5 squared. Let me write that down here. X plus 5 squared equals, and 6 plus 25, that's 31. Okay? You see that if we expand, let me do that here just a second. X plus 5 squared. If we expand this, remember the rule. This value squared is x squared. X squared plus 2 times this times this. So 2 times x times 5 plus this term squared, which is 25. I'm writing it as 5 squared. So if we simplify this would be x squared plus 10x plus 25. And this is exactly what we have here. That's why we can convert this to its factorized form, which is x plus 5 squared in this case, okay? That's why we call this method completing the square. So we can factorize and make this much easier to solve. So once we get this, you see that we're going back to this situation we already solved here, and we just need to take the square root and solve for x. So I will take the square root, let me do that square root on both sides. This is x plus 5 squared equals square root plus or minus 31. So then we simplify the square root with the square power here, and this would be x plus 5 equals plus or minus root 31. So finally, we have to do this here. So finally, this would be x equals plus or minus root 31 minus 5. So the two possible solutions are x equals positive root 31 minus 5 and x equals negative root 31 minus 5. So this is how we solve this equation by completing the square. Okay. So that's it for part A. Then I'm going to make a small division here for part B. Okay, so for part B, I'm going to start up here. We need to solve this once again by completing the square. Let's see if we can do this a little bit faster. So we have x squared minus 12x equals 3. What value do you think we need to add here in order to complete the square? Remember, is half this value and square that result. So in this case, half of 12 is 6, and when squaring 6, we get 36. So that's the number we need to add, 36. So this would be x squared minus 12x plus 36 equals 3 plus 36. Whatever I add here, I need to add here. So with this 36, we completed the square, and we can rewrite that expression as x minus, because we have a minus here, minus 6 squared, and that equals 39 in the other side, okay? So once we got here, this is easy to solve. It follows the same process as this. So we would just have to take the square root of x minus 6 squared equals 39 square root. We eliminate the square root with the second power. So we get x minus 6 equals plus or minus the square root of 39. So finally, x equals plus or minus the square root of 39 plus 6, if we take the 6 to the other side. So the two solutions are, the first one would be positive root 39 plus 6, and the other would be negative root 39 plus 6. These are the two solutions for this exercise by completing the square, okay? So I hope this is clear enough for you. Finally, we're going to see two last cases, and then we're going to leave the other two methods for the next class. We're going to see these two cases, which are a little bit more complicated than these first two we did. And we're going to see how to apply the same method, completing the square, but to solve this type of equations, okay? So it says, solve each equation by completing the square. Do you notice a difference between this exercise and the previous one? The difference is that now the coefficient in front of the x squared is not 1 as it was, but rather it is a number different from 1, right? So how does that change the completing the square technique? It changes a little bit. It says, in order to complete the square, the coefficient in front of the x squared term must be 1. If the x squared term has a coefficient other than 1, which is these two cases over here, before completing the square, you can factor out the coefficient or divide through by the coefficient. Okay, so you're gonna understand this through the example. So if I write the equation first, the rule is that this number should always be 1 in order to be able to complete the square. So one thing we could do here in order to make sure this is 1 is divide the whole expression divided by 2, right? So 2 divided by 2 would be 1, so this is x squared. 8 divided by 2 is 4, so 4x equals 6 divided by 2, this is 3. So this is something that it's much easier to solve by completing the square. What value should we add here to complete the square? Remember the rule, it's always half of this number and the result we squared. So half of 4 is 2 and we squared that value, so we get 4. So the value we need to add to both sides is 4. So this would be x squared plus 4x plus 4 equals 3 plus 4. So finally, we have already completed this square, so we can write the factored form of this, which is x plus 2 squared. Remember, is the square root of this term, equals 7. So finally, if I take the square root on both sides, x plus 2 squared equals plus or minus root 7. We would get, on this side, the square root cancels out. So we will get x plus 2 equals plus or minus root 7. So the two possible values of x are positive root 7 minus 2, and the other is negative root 7 minus 2. This is how we solve by completing the square in this case, okay, where we have a coefficient in the x squared different from 1. Let's see the last one, B, to wrap this class. So part B, we have this situation over here. 3x squared minus 15x equals 2. Once again, we can do the same thing. We can divide the whole equation by the coefficient we have in front of the x squared, which is 3. So if we divide, we would get x squared minus 5x equals, and this would be 2/3, right? We'll have a fraction here. You can just leave this as a fraction. So we need to complete this square. To complete this square, I need to take half of this number. Half of 5 is 5 over 2. And we need to square this value, which would give us 25 over 4. So this is the term we need to add to both sides of the equation in order to complete the square. 25 over 4. So I'm going to leave that there. There you go. So this would be x squared minus 5x plus 25 over 4 equals 2/3 plus 25 over 4. Okay, so we have completed this square over here. So this would be x minus, because this is a minus, and this would be 5 over 2. It's always this term over here, the one that completes the square. So 5 over 2 squared. Let me write this parenthesis better. There you go. So this equals 2/3 plus 25/4. That should be 2/3 plus 25/4. That gives us 83 over 12. And if we take the square root on both sides, let me copy this. Here, we would get, we need to take the square root on both sides. Square root. So this cancels out, this was this, and we would get that x minus 5 over 2 is plus or minus the square root of 83 over 12. You see that we're getting kind of ugly numbers, but that's fine. So the two possible solutions would be, one solution would be x equals a positive root 83 over 12 plus 5/2, and the other possible solution would be negative square root of 83 over 12 plus 5/2. And those are, oh, I forgot to write the x. Those are the two values of x in this case. There you go. So these are the two solutions using completing the square method. Okay, so I think this, I hope this is fine for you. I hope you understand this clearly. If not, please let me know that you have doubts, and we can cover this in our future live session or throughout another communication media. Okay, so I hope you have a nice day, juniors, and see you.